So hello everyone, thanks for attending our conference. So yeah, as said, today we're going to talk about LiveWire and more specifically remote command execution through Unmarshalling. So who are we? We are both working at Synactive, which is a French specialized company in offensive security. We do penetration testing, reverse engineering, etc. We are now almost 200 experts over 6 offices in France, and we are working with companies all around the world. So I am Pierre Martin, and my colleague is Rémi Matasse, and we are both pen tester and researcher. So, today we're gonna introduce to you what's LiveWire, how it's working, the synthesizer mechanism, then the checksum generation, then Rémi will talk about the Unmarshalling chain that we found from the synthesizer, how to get a PHP info into a remote command execution, and then we will present a tool that we made to actually exploit this automatically, with a demo, of course, and Rémi will end with a conclusion. So, what's LiveWire? LiveWire is a component of Laravel which is used to link front-end and back-end objects and is used on more than 700k instances inside the internet, and it allows to build real-time features like if you change your object on the front-end, it will update it on the back-end, but you will not have to reload the page or things like that you must do in PHP to have some updates. So, to build a simple component in LiveWire, you have to create the actual file in app/LiveWire. Here we have a very simple counter with just increment or decrement a counter. So you need 3 things. You need this component to handle the user interactions, a route pointing to this component, and a blade reference, which is just a view to be rendered to the actual user. So this is the web.php, which is the routing file of Laravel, and the view which just displays the actual counter value and allows the user to execute increment function or decrement function. So what's happening? You have our little page, which is ugly, but just for the example. When you are interacting with the actual LiveWire instance, when you click on the plus, for example, a request is made to /LiveWire/update. And of course, if you click on minus, the request is the same, but the content is not. So, what's LiveWire sending when you actually click on plus? LiveWire is sending a lot of things in a JSON format. First, it will send the path and the method, and which are based on the current pages to just identify where the user is on the actual application, to know which controller must be called to treat the object. 2, we'll have the calls which contain the actual methods that must be called on the object. Here, if we click on the plus, we have the increment function, and if we click on the minus, we have the decrement function. 3, the data, which contains all the fields associated to the current component and the current component value, which is here 1, and when the user click on it, it will be 2 after. And then the checksum, which is a hash calculated by the server, which allows integrity checks, because in the data, in the method, etc., you might think that we can put what we want, but you actually can't, because the actual calls that are made to LiveWire in the JSON format are already pre-computed by the server, and the checksum is here to just be sure an attacker don't modify the data that are sent to the backend and do some nasty things like call whatever method he wants, etc. So, to handle those requests, LiveWire use what they call synthesizer mechanism, which just allows to define custom JSON types that should be dehydrated or hydrated. For those that might know, this is the same comportment as C#, as they are doing with the JSON types. So, LiveWire by default offers default synthesizer for generic custom types. They are like 10 of them, but we just put 3 on the slide just for you guys. You can see what they do. So, for example, the WRBL, which is just a writable value that can be hydrated and dehydrated, str, which obviously represents a string, and a one that will be pretty interesting in the Rémi part, CLCTN, which is the Laravel collection that is hydrated and dehydrated, by converted arrays, objects, etc. And of course, if a developer wants to add a custom type, he can do it. He just have to create a PHP class that extends from the synth class, which is the base class of LiveWire, and his class will be potentially be used as a synthesizer. On LiveWire, some default hydrators support embedded objects. As we see before, CLCTN supports embedded arrays, embedded objects, etc. And this might allow recursive hydration, and that will be very interesting for our exploit. And in LiveWire, there is 3 default synthesizer that allows this recursive hydration. We have CLCTN, which is collection synth, form for form object synth, and MDL. So, here is the source code of LiveWire with the example of the collection synth synthesizer. So, for any synthesizer of LiveWire, you have to declare his name. The name that you see, CLCDN, is the one that will be used in the JSON request that will be made to the server. So you have to use that. The value represents the serialized collection data that we see before, like the count with the value 1, as we see in the previous example. The meta, it's an array containing metadata about the current object, and hydrate, which is the callback that will be used individually to process each element of our request and how the object must be updated. Of course, synthesizers come with strong restrictions, and collection synth was the only one that we found that might be interesting for an attacker, because if you check the live number 12, we have the return new meta class $value, which is like an arbitrary class instantiation if you can control those values. And actually that's the case. You can control the class value of the meta array and the $value, of course. So with the following synthesizer, you are allowed to instantiate any class from the PHP actual code base with 1 parameter for the constructor. So when we see that, we are pretty happy. We found that we might be able to do something on it, but we found that we need some prerequisite for the exploitation, because as I've said in the beginning of the presentation, is that the JSON that is sent to the server is actually has actually a checksum that allows integrity for LiveWire to check if the message that is sent has been modified or not. So for this exploit, you will need the Laravel app key, and you will need the valid LiveWire request, but this is not very hard to have. But the big prerequisite here is the Laravel app key. Why you need that? Because if we just give a shot on the checksum generation, we can see that the checksum generation is is taking the snapshot from the JSON request and is signing it with the actual Laravel app key of the application. And it will just render it to the user. And this, when you send the request to LiveWire, will be checked with the following method. And it will take again the snapshot that has been sent by the user, will compute the checksum, and it will check if this match the altered checksum that was originally in the JSON. If those match, LiveWire treat the request. If there is something wrong, LiveWire just throw an exception and deny the request. I will now let Rémi talk about the Unmarshalling chain that we found.
Okay, so now that you understand a little better how LiveWire works, let's get things a little bit magical. So, yeah. So in PHP and in many other languages, there are what we call some magic methods. So just to be clear, let's see how it's described inside PHP documentation. So PHP says magic methods are special methods which override PHP's default action when certain actions are performed on an object. So basically, to recap that means that that's functions that will be called inside PHP object lifetime. So they might be triggered at some point or not. It depends on the situation. So we will need to clarify some of them just to show you how it works, because that's the main root point of our following exploits. So the most common one is the construct method. It's called when you create a new object. We were talking about arbitrary instantiation, so that's basically our entry point in any of the following gadgets I will show you. There is also the toString magic method, which will be called when you try to use a PHP object as a string. So basically when you try to print it, that will be called. There is also the invoke method, which will be triggered when you try to use an object as a function, like that. The destruct magic method, which will automatically be called when an object is no longer in use. So it was mainly an entry point for unserialization gadgets. And finally, the wake up method, which is called when you try to unserialize an object. It will be the first method called when you do so. And so it's really interesting to have this little clarification, because most of the time, some gadgets used when you do unserialization in PHP are patched inside the wake up function. So that means that we might be able to use those gadgets when we are trying to do some arbitrary instantiations. So right now, what we are looking for is basically an Unmarshalling gadget. So that means we need to find some functions inside Laravel, inside Laravel objects or LiveWire objects that we might be able to instantiate arbitrary, as described Pierre just before. So what we want them to do is first to be compatible with one of LiveWire synthesizer, of course. We also need them to have only one purpose. We need to keep that simple, because you will see that there are so many things that will work together. We just need our gadgets to do one particular thing, and that's all. And finally, we want them to be chainable together, because we can, with a CLCTN, for example, synthesizer, chain gadgets together, and that's where the true magic will start to become, as we will see. So the best and easier tip, as I said, since unserialization gadgets are patched inside wakeup, and that wakeup is only used when you do unserialization, we want basically to find an old gadget that is patched against unserialization, but that will work inside Unmarshalling. So that's what we are looking for, something that has been forgotten to everyone. So if you worked with PHP, you might know the infamous fnstream object. So basically, what does it do? There is an easy construct right there that we can use, because as Pierre said, inside the CLCTN synthesizer, we need to have a constructor that takes one array as a first parameter. So that's exactly the case, as we can see there. It does work. After that, we can reach destruct or toString functions from the object. And basically what it will do is that you can have an arbitrary call to an arbitrary function via destruct or toString. So that will be our main object during this chain. And so basically the first thing that we would to do during step 1 will be to have an arbitrary call to a function called PHP info. This function will tell you many things like environment variables or something like that, which are really, really great to have when you are working with Laravel from an offensive side. But, you know, we cannot just use fnstream by itself. We try to do so, and for some reason the destruct method was not directly called. So we needed to find another gadget in order to reach the toString method, which is shared prefix public URL generator. And so basically, once more it will work because it's compatible with CLCTN synthesizer. As you can see there, the constructor takes one parameter, which is an array, so it works. And inside this constructor, as you can see there, there is what we call strong typing as string right there. The prefix will be fnstream, and so we force it to become a string, so its toString function will work. So here is a little recap of that. As we can see, we have our FN stream gadget, which we want to do is a PHP info, so that will have this form. We force its toString function to be called by doing a strong string typing on it directly. And so, you will see that it's really magical, but you've got your PHP info. So that's only the first step. So, as you might guess, we won't stop there. We want to have a remote command execution. And we want to find other gadgets allowing us to reach this point. So basically, we need other gadgets. So, from FN stream, we can really call many other gadgets, because from an arbitrary function instantiation, we can call what the invoke function of any object defined inside Laravel and LiveWire. And so from this point, we're able to reach the class signed and to build a signed gadget. So right there, as you can see, we're able to reach the call user func array function. And this one allows us to call any public function from Laravel. And as you can see, it's like Russian puppets, and each gadget will have one purpose, and this one will be to reach any public function inside Laravel. So we can use any function from this form, public function that takes no parameter. So now we need to find another gadget, one that allows us to reach a function that takes no parameter inside the public function. And so that's when things start to get really interesting. There we need another gadget, which is broadcast event gadget. As you can see, it does implement a constructor with only one parameter. So we are able to reach it from the from synthesizer. And from this point, we are reaching the public function dispatch next job in chain. And so, from one gadget to another, we finally reaching something interesting. There we have an arbitrary call to answerization. And if you followed what we said, answerization is patched against many things, but the fun fact is that in fact, in Laravel, it's a huge improvement, because we don't have anymore some strong restriction on what we can call or not. And so, in fact, their answerization is really a big upgrade, because from a answerization gadget point of view, Laravel is huge. You have dozens of working SE from answerization inside Laravel, and they won't patch it, so you can use any of them, even some older one that works on almost any Laravel version. And for example, in the following of this talk, we will work with Laravel SE4, which will trigger an arbitrary remote command execution from this dispatch next job in chain function that we said. And so that's how we do it. As you can see there, by using this gadget and many others, you see that the payload starts to get really complicated, but trust me, it works. As you can see there, we have our first remote command execution. But things does not stop there, because, yeah, it works, but we've got some verbose log inside Laravel. It's not really sneaky, it's not really that interesting, because it will trigger any alert in the world. So what we wanted to do is to transform our payload and to make it clean. Because, for example, if we use this tool during red team, we don't want to get caught, So the final step is to make our full payload sneaky. So how do we do it? We've got error triggers everywhere. We've got verbose errors such as 500, as I said. But we are able to make it fully sneaky. Why? Because all the payload is working from a post request on a legitimate path, which is LiveWire update. And so if it answers with a 200 status code, it's totally sneaky, it's stealthy. So the first thing we do from this point is to make the gadget Laravel RC4 from answerization working with our broadcast event gadget. And so it does not stop Laravel flow. But anyway, after doing so, LiveWire will still crash because we are working with our component, and its flow will stop at some point because why is there so many functions? It does not know where it lives anymore, and so there will be errors still. And that's pretty funny and easier gadget to understand. The terminal gadget, which is quite cool to finish on this one. It's basically a gadget used to call an exit. And so from the exit, we stop any flow inside Laravel, and we go from 500 errors, verbose errors anywhere, to a fully working payload that is not triggering any exceptions anymore. And as you can see now, the payload is fully sneaky, and if you check your Apache or Nginx or whatever logs, it won't appear anywhere. You will see only a 200 status code, and it will be fully sneaky. And so there I can do whatever I want. There, that's only an ID, but I may be able to do anything else. And so from this point, you see this snapshot that is quite huge. It's fully sneaky, and you can pawn any server as long as you've got the app key of it. And yeah, you know, it seems quite simple like that, but it took us 2 months in order to find all these little gadgets and to make them work together. And we finished the fully working payload at something like 3 a.m. and we were really tired because it's been months, and yeah, it was quite satisfying when everything worked together. Now I will let Pierre explain you how we fully authenticated all of that inside our tool laravel-crypto-killer.
Thank you, Rémi. So, for those who might not know, laravel-crypto-killer is a tool that already exists, which is developed by Rémi, which allows to brute force Laravel's encryptions cookie to get the app key with a word list of app key that Rémi made 2 years to make. And to this tool, we had another thing, which is the exploit method, which now just have the LiveWire exploit, but maybe more to come after. This exploit will take, of course, the app key of the applications to compute the checksum. It will take a JSON parameter, which actually represents the JSON request that is sent by the LiveWire that you are targeting. Just the full JSON request. You don't have to just take the token or just copy paste the JSON and we'll treat with the tool. And of course the function and with the parameter that you want to execute, and by default the tool is running system with the ID command. So how is it working? The tool take a legitimate LiveWire request. We modify the request data and we recompute the checksum with the actual payload that Rémi shows you on his burp suit screenshot before. And then we output to the actual user of the tool the malicious LiveWire request that just needs to be copy-pasted into burp suit or into a curl request to trigger the remote command execution. So, when I was talking about a JSON request, is just the whole post data that you see here. Just you copy paste this into a file, you give it to the tool like this, and the tool will output the full Unmarshalling chain that we are using to gain remote command execution on the LiveWire instance that you are targeting. And don't worry, this is a default app key that is public too. So it gives us things like that. So like we said before, a big payload. Quite huge, but you get your remote command execution with a 200, and you get under the hood. So, to have a quick demonstration, and sorry for Nullcon guys which are using actually this tool, we take an open source project which is called SnipeIT, which is just asset management, you know. They have a vulnerability which Rémi targets on them, is that they have a default app key on the .env file that you can find in the GitHub repositories. And as people are not following the rules, they are not generating again an app key to have a random one. So just having the app key from the original .env files might allows you to gain remote command execution. So, the actual LiveWire requests that are made on SnipeIT might be something like that. There might be others, but we just took this one because it was easier. So for here, you can see that we have just a progress attribute in the data that will be targeted. And then we will use the tool on it to gain remote command execution. So, SnipeIT, this is the login page of SnipeIT. You can get a LiveWire request also by trying to log in into the application. As you can see, we don't know the password. So, to be realistic, we take the XSRF token, which is an encrypted value with Laravel app key. We use Rémi's tool, laravel-crypto-killer, to brute force the app key. And of course, we found one, but that was the default one, that was a SnipeIT. Having this app key might allow you now to trigger the LiveWire exploit that we talked about before. So, you specify the exploit is LiveWire, the app key, then you copy-paste the JSON post data that we see before into a file, here SnipeIT livewire.json. Then you can specify the function to use. Here we use the system function with the id command. It generates the full chain here. So you might then copy-paste it into Burp Suite, into Curl, whatever. We do it with Curl because it's simpler for us for the demonstration. Then we reach the LiveWire updates, the routes, which is the default route of LiveWire that we treat our requests. Don't forget the content type application JSON. Copy-paste the payload, and this gives you a remote command execution without any logs with a 200 status code. And I will let Rémi end with the conclusion and some thoughts.
So as we can see, web is not always that easy, and sometimes there are some unexpected, surface that you might come to, and just try to put so much thing together so it will work at the end, even if it takes some months. And yeah, this was really an interesting research to do. So we made it happen that from a default app key plus the usage of LiveWire, you get a remote command execution. So at this point, it's a vulnerability, of course, because you can compromise some servers with default app key. However, we discussed the matter with LiveWire teams, and they did not consider this as a vulnerability, since being in possession of the app key is considered as a strong prerequisite. And so, yeah, the bad news is that it won't be patched. But the good news, if you are working in offensive security in general, is that since it's not considered a vulnerability, you will still have a backdoor, if you like, on Laravel applications based on LiveWire. You just need to have the app key, so if you get your hands on it at some point, well, you still have an access forever on the server. And so, during our research, and while also applying for the CFP during Nullcon, we continued to have our research because we were a little frustrated to, finish out something that's not really considered a vulnerability. And so we continued to do some work because after so many months working on it, we piled up some knowledge on it, and we really deeply understand the internal mechanism beneath LiveWire, which led us to find something considered a vulnerability this time. And we found a way to trigger a remote command execution, but this time without the app key. So this time, of course, LiveWire security team patched it, and CVE was assigned to it, which is CVE 2025-54068. And this one is quite impactful because it really targets the default behavior of LiveWire. But, as you saw, there was already so many things to discuss during Nullcon. So we did apply for other CFP in order to go deeper inside this particular vulnerability. So yeah, there are other things, other tools, and if you want to continue our journey with us, inside LiveWire components, stay tuned. We might, maybe, hopefully, get taken inside another conference in order to continue this little journey and to show you how we can mess a little more with LiveWire components. So we really hope you did enjoy this this presentation. It took us so many time to, put something together so it will work. And we really hope that we did not lose you because there were so many gadgets explained, and that you enjoyed your time with us today. If you have any further question, of course, we had to make things a little simpler on some point. If you want to have more details, please reach to us. We'll happily answer. And stay tuned. There is more to come on LiveWire. Thank you.
I think we have time for questions. Anybody has any questions?
Thanks for the interesting presentation. I was just wondering, were you able to make your life a little bit easier to find any of these gadgets, like with some automated tooling, like, okay, we scan for functions that have these many parameters or something like this? Or was it just pure, like, hard work for 2 months?
We did use some really, fancy tools like grep or xdebug, but we did not really automated the whole process because there were so many edge cases. For example, as we show, you need to have some particular constructors, and there were so many restrictions on it that we don't show all the code after the construct, but many times it does trigger an error which breaks all the gadgets. So we cannot just base ourselves on the constraint on the constructor for each functions, because sometimes something will break something inside the whole process, and so we really had to dig on each class to see if something is broken or not after the construct, and to see if it's working or not with the gadgets we already had. So that's why we tried to keep everything simple, and for each gadget to do one particular thing that won't break everything together. So it was 2 months of hard work.
I see. And is there any other way that you know of how these app keys get into the hands of an attacker? So are there other ways they get usually leaked, or is it just default keys? Or is it so easy to brute force it actually? Usually it should be totally random, right?
Yeah, so by default, all the app keys are fully randomly generated. We did a full blog post on this subject if you are interested with with the top 10 of the most used app keys around the world. And in fact, the main issue with app keys is that people will copy paste it with default .env files and default configurations. And when you share an application, for example, it was the case for many time with Snap IT. It's not the case anymore, but as you saw, we were able to break it, because it's a public project, so you have a default configuration on it, and the app key was not rotated automatically when you installed it. And so when you share a Laravel project, that's a really common mistake done by developers on public projects or etc. If you want to more details on it, we made a full blog post, so you can have more details, or we can discuss it if you like after the presentation.
Okay, thanks.
Any other question? All right, then thank you so much.
Thank you.
Thanks everyone. Thanks for having us.